am Dr. M.Hemalatha from K.B.N college in the Department of Physics and Electronics. I want to share something about the concept of LED, which is the concept in 5th semester physics of subject electronic instrumentation. Firstly, LED is a display device. LED stands for light emitting diode. So any diode contains two terminals. One is cathode and another one is anode. Just like that, LED also contains two terminals named as anode and cathode. LED is connected in forward direction. So in forward direction, anode becomes cathode, cathode becomes anode. In nowadays, LED is very familiar and valuable material because it can work with low voltage, it can available in cheap cost, it emits light with high intensity. So just like these parameters, it is very valuable material in nowadays, very useful in nowadays. So the diagrammatic representation of LED is like this. So the black color diagram is the symbolic representation of LED. It contains two terminals, anode and cathode. So LED is in forward direction. So anode represents the positive terminal, cathode represents the negative terminal. So in that image we are observing two arrow marks. That arrow marks represents the emitting of light emission. So this is the second image is the normal LED we are seen in nowadays. We have seen in the laboratories also. It contains two terminals. One has longest length and another one has the shortest length. The longer length terminal is the anode terminal and the shorter length is the cathode terminal. So we can observe LEDs with different colors. The emitting of light with different colors is on the basis of mixing of components. So in general, we prepare LEDs with three chemical components. Those are phosphorus, arsenide and gallium. So by mixing of these three colors with suitable proportion, we can get the different color. So by mixing of the components of gallium and arsenide, we can get the light of LED, but it emits infrared radiations. They are invisible, so we can't observe the light. So by mixing of the gallium with arsenide and phosphide, we can get the light with red and yellow color. And also just like by mixing of gallium with arsenide, we can get the coloring of LED light with red and green color, and they are also available in blue and orange color also. So this is the construction of LED. So LED constructed with two types of materials. It is a semiconducting material made with two types, P-type material and N-type material. So there is a region in between P and N-type material. In that region, the lightning process has been done. So in this image, the lower is the base of the LED. That base we call as the substrate. On the base there is a material has been coated, that is the N-type material. So N-type material is a special material that contains particles with the positive charge and negative charge. So in N-type, the more number of particles should be negative charged particles. That negative charged particles we call as the electrons. In P-type material also contains two type of particles with positive and negative charges. So but in P-type material, the more number of particles should be positively charged particles. That positively charged particles are called holes. So by giving the external energy to LED, the process should be starts movement of particles from P-type region and N-type region. They are moved forward to active region. In active region, here electrons are highly energetic particles and holes are less energy particles when comparing to the electrons. In active region, electrons and holes can recombine, and additional extra energy from the electron has been emitted in the form of light. That is the entire process, the emission of light in LED. So this is the light emission process. So here there are two types of materials, p-type material and n-type material. In p-type material, the white particles are more number when compared with the gold color. So here white type particles are positively charged particles, we call that as holes. In n-type region, there are also contains two different particles with two different colors, white and gold color. So white color particles are holes and gold color particles are electrons. So in n-type material, more number of particles should be electrons. So here there is a source connection indicated with the positive and a negative symbol. The positive terminal connected to p-type material and a negative terminal connected to n-type material. While giving the energy from the source, the movement of electrons from electrons starts to active region, and the movement of holes from p region starts to active region. In that region they recombine, and here electrons are highest energy particles and holes are less energy particles. The external energy has been released from the electron in the form of light. That is the process of emission of light in LED. So this is the energy gap of the LED. So LED contains two energy band gaps. The one is the lower energy level and other one is the upper energy level. So lower energy level we call as the conduction band, and upper energy is the low energy is the valency band and upper energy is the conduction band. So lower energy contains holes, upper energy contains electrons. While giving energy to LED, the holes from lower energy or valency band can jump to upper energy and they can meet with electrons, and after very less time, that is almost 10 power minus 8 seconds, they recombine and get back to valency band. In that process, additional energy from electrons can be released in the form of light. That is the process of emission of LED. So this is the characteristic studies of LED. That means how the LED is lightening. So if the LED is lightening due to the giving current, so this is the graphical representation. The graph has been done in between forward current and relative output. So relative output is nothing but the intensity of the light. So here the graph should be straight from origin. That means it is continuously increasing. If more current, more intensity, less current, less intensity. That means lightening of LED is completely dependent on the giving current. Nowadays LEDs have many advantages due to some special properties. They are available in less cost and they are readily available when we buy. Next, they are lightweight materials. They occupy small space and also have long life. So next, we can easily interface with any other electronic devices, and we can operate LEDs with certain temperature ranges from 0 to 70 degrees centigrade, and they are available with different colors while mixing different compositions like gallium, arsenide and phosphide, and emit the light with red, green, yellow, orange and blue. They can withstand to shocks and vibrations. They occupy in small space. So LED have these advantages. Applications. We are all in LEDs world. They are applicable in many fields, just like offices, just like warehouses, health centers also useful for LEDs, and signal indicators also made with LEDs. Street lights also made with LEDs. Showrooms also made with LEDs. Theaters, sports venues. So the entire world is with LED due to the due to have many advantages like they can run with less voltage, they are available readily, we can interface with them for any electronic devices, and they are in small size, we need small size materials, they run with more lifetime, they can withstand with shocks and vibrations due to the special properties of LED. They are useful in many applications. Thank you.